In this video, I will show you how to test the differences between means and independent samples. We will talk more about dependent samples next week, but independent samples refers to two separate groups under study. For example, we might study the difference between men and women in their average number of hours of sleep each night. The men are in one group and the women are in another group. These groups are independent in that they are mutually exclusive, and we're interested in how these two groups differ. We use what is called a t-ratio to assess differences between these groups to see if any differences we might find in sleep patterns are statistically significant, or in other words, represent a real difference. Or we can see if the differences are merely due to sampling error, and in truth, both men and women in the population have the same mean for number of hours slept. When we test a hypothesis in statistics, we have the research hypothesis, which is sometimes called the alternate hypothesis. The research hypothesis is what a sociologist expects to see. We also have the null hypothesis, which is what we actually test. The research hypothesis is that the means for two different groups on some dependent variable are not equal. And the null hypothesis is the opposite of this claim. That is, the population mean for two groups are equal. In the last video, we talked about confidence intervals, and if you will recall, the formula for confidence intervals is based on the formula for t. We use t-scores when finding confidence intervals when we don't know the standard deviation for the population, which is almost always the case. When we don't know the standard deviation for the population, we use the z-distribution. We are also going to use the t-distribution to test whether the means of two groups are sufficiently different for us to conclude that they are actually two different populations. If the means are not sufficiently different, that leads us to conclude that any differences between the two means is just due to sampling error, and that in the population the two groups have the same mean. With confidence intervals, we needed a t-value, which we obtained from a table, a sample mean, and an estimate of the standard error. Testing for differences between the means of two groups is essentially the same formula, but we replace the means with the differences between the means. So instead of one sample mean, we look at the difference between two sample means. And instead of subtracting the means, we subtract the difference between the population means. Finally, the denominator, instead of a standard error for a sample mean, is a standard error for differences between sample means. So the formula that your textbook presents is right up here. And as you can see, the t is equal to the mean of one group minus the mean of the other group over the standard error of the differences between means. Definitely the hardest part of solving this equation is calculating the standard error, which is found right here. You can see that calculation is quite complex. But just like with standard error for the mean, which we calculated for confidence intervals, this standard error formula requires just that we know the ends and the variances. So in other words, it has very few unique variables. In order to illustrate t-tests for differences between means, let's work through this problem in your textbook. The problem states, a social researcher is interested in understanding the effect of college education on wages. Listed below are the hourly wages for two groups of employees, all working in the same position at a particular technology firm. The workers in one group have earned an associate's degree, while members of the other group hold at least a bachelor's degree. Test the null hypothesis that there are no differences in mean wages by degrees held by employees. All right, so the first thing that we need to do is take the data that's in your textbook and put it on our Excel sheet. I'll do that right now. And with the magic of editing, here is our data. Each of these numbers represent the data point for one employee and reflects the hourly wage for the employee. The research hypothesis is that the average hourly wage for workers with an associate degree is not equal to the average hourly wage for workers with a bachelor's degree. This particular research hypothesis does not specify a direction, as in which group has a higher hourly wage, but rather just that there is a difference in hourly wage between those with an associate's degree and those with a bachelor's degree. On the other hand, the null hypothesis is that employees in each group have the same average hourly wages, that there is not a difference between these two groups. Going back to our T formula, I see that I'm going to need the means for each group right here, along with the standard error of the difference between means. And when I use the table to find t, I know I'm going to need to have the degrees of freedom. So on the left, I've assembled everything that we're going to need to plug into these formulas. So again, the t formula says I need the means of both groups and the standard error of the difference between the means. And wow, that formula is a doozy. But however, all you need in this formula are the ends and the variances. So we can do that. We figured out variances in chapter 4, and we're going to start with finding some of these things on the left. Okay, so we need first the number for each group. And did you know that Excel has a count function? Makes it easy. So I'm going to go to Formulas, Insert a Function. I already have the count here because I've used it recently, so I'll just take it. I'm going to select all those in the Associates group, and we have 10 in the Associates group. It's easy, of course, just to count them, but I'm going to use this function for grins. Okay, so we have 10 in each group, so we have that part of our information entered. The next thing that we're going to need are the means for each group, so I will do that. I'm going to press enter, or equals, sorry. Insert function, I'm going to select average, because that's our word for mean. I'm going to select those in the Associates group, press return. So the average hourly wage for those in the Associates group is $10.36 per hour. I will do the same for the Bachelor's group, equals. And if your Excel may have the same feature depending on your version, but I used average the last time, so it left it there for me to select again. I'm going to select all in the Bachelor's group, hit return. So the average hourly wage for the Bachelor's group is $11.32. So I just want to take a moment right here and ask, are the differences between $10.36, or is the difference, and $11.32 a real difference, or is that just a product of sampling error? So our t formula is going to take into account a couple different things, sample size and variability within our samples, to figure out whether or not the differences that we're seeing are real differences or if they're just due to chance. And so the next thing that we're going to do is calculate the variance. And if you will recall, you can calculate the variance in two different ways. And I'm going to use the sum of squared deviations form with this example. And in order to do that, I'm going to put some new labels on my data table. And boom, there they are. So I know that if I'm using the sum of squared deviations formula, that I'm going to first need to find the deviations for each score. So I do that by pressing enter, selecting the score, minus, and then of course the mean of the first group. I'm going to want to drag this formula down to apply to the others, so I'm going to insert some dollar signs. Enter. And I will take this, drag it down. And I'm just curious to find out if I've done this correctly. So I'm going to sum these. And what should it sum up to if I have done my deviations correctly? Anyone? 0, and it did. So I know that I've done my deviations correctly. Now I'm going to square my deviations, each one, starting with the first one. The deviation, caret, 2, return. Way too many decimal places. We'll fix that in a moment. Alrighty, I dragged it down. I'm just going to format this to be 2 decimals to make my life easier. And then I'm going to sum all of these up, and I end up with a sum of squared deviations of 5.28 for the first group. So I'm going to enter for the variance, not just this number. First I'm going to enter this number, 5.28, and then I have to put that over the number of people in the group. That's our formula for variance. And I end up with a variance of 0.53 for the first group. Now let's repeat this for the second group. Equals the first score minus the mean of the second group. Keep it constant by putting dollar signs around each cell. Press return. Drag down. Be super compulsive. You end up with 0. Yay! And now we're going to square our deviations. Square 2. Somehow we're winding up with way too many decimals yet again. And there we go. Drag these down. I'm going to sum them up. And the sum of square deviations for the second group is 12.22. So in figuring out the variance, I'm going to do equals 12.22 over the n of 2. And that gives us a variance of 1.22 for the second group. And let's just figure out our degrees of freedom while we're here. We have equals the n of 1 plus the n of 2 minus 2. Of course, I could have just done that in my head, but when you're doing your homework this week, I want you to go ahead and plug in the formulas for each of these things. That way, if there's one area that you're having some difficulty with, I'll be able to go in and see how you're coming at your answers. So don't just plug in any answers by typing them in, but actually use the formulas on your homework. All right, so now I have the sample mean and the variance for each sample mean and the sample sizes. That gives me everything I need to do to calculate the t-score. So we're going to start with the t-score by finding the standard error. And I'm going to calculate this formula in steps because it is so large. But when I'm finished, I'm also going to show you how it can be calculated in one fell swoop. And your practice assignment this week involves using Excel to calculate a t-score. You can choose to calculate step by step or all at once, whichever you prefer. However, you are, like I said, required on that assignment to use formulas such that I can click on a cell to see how you arrived at your numbers. But for now, here we go with the step-by-step method. I'm going to plug in some new helpful cells. And if I'm going to take this standard error, the difference of between means, piece by piece. This is just one way that you can take it piece by piece. You may have a different way of doing it, and that's perfectly fine as well, just as long as you enter the formulas into the Excel sheet. So I've labeled each of these steps A through G, and the final step is going to be the standard error. So we'll walk through this one part at a time. So the first step is going to be to find the numerator of this side of the equation. So that is the n of group 1 times the variance of group 1 plus the n of group 2 times the variance of group 2. Let's plug that in. N of group 1 is 10 times the variance of group 1 plus the n of group 2 times the variance of group 2. And that gives me a figure of 17.50. The denominator of the left side of the formula you may recognize as your degrees of freedom, but we will plug that in anyway, equals n1 plus n2 minus 2. And that gives us the degrees of freedom of 18. The third step, as you will notice here, is to divide the numerator by the denominator within the parentheses. And so I've got that right here. Here's the numerator, here's the denominator. So I could do equals 1750 over 18, and that gives us 0.97. And that's going to be what is in this parentheses now is 0.97. Now let's work on the right-hand side of the equation. In this parentheses, we have a numerator. That's n1 plus n2. So n1 plus n2. I know you could have just put 20 in there, but I want you to plug in the formulas. And then the denominator is n1 times n2. So what is in n1 times n2? Return. The next thing we do with this right-hand side is to divide the numerator by the denominator. So that's over here d minus e equals, or d over e, sorry about that. Okay, and that gives us 0.2. And I just, for my own compulsive nature, I want to make these all 2 decimals. Okay, all right. And now the last step, not the last step, second to the last step is to multiply what is in this set of parentheses by what is in this set of parentheses. So we have this times this. We have the left side, 0.97, times the right side, 0.20. And that gives us 0.19. but we do need to find the square root of this whole inner equation. So I'm going to put an equal sign, and SQRT tells me to put a square root. I'm going to need to put this in parentheses for Excel to figure it out. I selected the term above, and that gives us a standard error of 0.44. Very good. All right, so now I'm going to do the big standard error without using separate steps. You may or may not want to do this. It just depends on how comfortable you are with the order of operations and with just combining a lot of steps together. So I'm going to take the formula over here and just plug it into this here. I have equals square root. And I'm going to use a parenthesis mark for the whole term first. And then within that, I have the left side term. And within the left side term, I have the numerator. So that's a lot of parenthetical marks. I don't know what you call them, but here we go. So now I'm ready to do this first part, which is equal to n1 times the variance of 1 plus n2 times the variance of 2. Now I have to close the numerator, and I have to put this over the denominator, which I'm going to put in parentheses, another set of parentheses, and that is n1 plus n2 minus 2. I'm going to close the denominator, and then I'm going to close the whole term. There you go. And you can always look at your parentheses to see how you're matching up. The whole term, the whole equation is represented with a black parenthetical mark, but then the left side term starts with sort of a pink mark and it ends with a pink mark. So now I know that I've done the whole left-hand side at least. I know I'm going to be multiplying these two sides together, so my next step is to put a multiplication sign. And then I need a parenthesis for the right side, and then I'm going to need a parenthesis for the top term, which is n plus 1 plus n plus 2. I'm going to close the numerator, and that is over the denominator of n times 1 times, or n of 1 times n of 2. I'm going to close the denominator. I'm going to, and I just saw that I didn't put, yes, what did I not do? Hold on just one moment. Okay, I spotted an error before it was too late. So the right-hand side of the formula starts with a grand parenthesis here. Then there's a parenthesis over the numerator, and I didn't put one to start the denominator, and that's what I need to do. That's okay, you can do that. And I've already closed the denominator. Now I have to close the whole right-hand side of the term. And finally, I'm going to close the whole kit and caboodle. There we go. And I can see that I started with a black parenthesis and I'm ending with a black parenthesis. So I'm hoping this will work. I'm crossing my fingers that this will be the same standard error. And it is! Hooray! I don't have to re-record this whole video. That is very good. Okay, just going to quickly format this to 2 decimal points. All right, and now we have a standard error of 0.44, which is the same standard error we got if we did it by a bunch of steps. It's going to just depend on your own preference. My guess is a lot of you are going to want to break it down into different steps, and that's perfectly fine. And now that we have our standard error of 0.44, we can calculate our t-score, and that's the easiest part of all, really. So t-score, we're going to put an equal sign here. In parentheses, I'm going to put the mean of the first group minus the mean of the second group. So just looking over here, that's the numerator. And that's going to go over the standard error that we just determined in 2 different ways. And that gives us, again, here we go, just one moment, gives us a t-score of minus 2.19. Okay. So in order to test our null hypothesis, we have to compare this, what we're going to call our observed t, to a t-value from table C in the back of the book. And our degrees of freedom we're going to need, if you'll recall from our confidence intervals, our degrees of freedom we determined are 18. So let's pull up the table that's in the back of the book. we're going to find degrees of freedom 18. And once we find degrees of freedom 18, we see a whole bunch of different values for t based on different levels of alpha. So we're going to choose the level of alpha of 0.05. That's what we generally use in social research. So if we take 0.05 and we draw down, we see what's called our critical t value is 2.101. So I'm going to put that on our paper, on our Excel sheet, 2.101. Okay. So what we're going to do now is compare our observed t to the critical t. And if our observed t is bigger, then what we're saying is there really are differences between these two means. Because our t is 2.19 and the critical t is 2.10, it would be very unlikely for us to see a difference in means of that size if both samples came from the same population or if both population means were the same. Now recall that even though our t has a negative symbol, we just disregard that when we're using the t-table. So our t-score of 2.19 is larger than the alpha for 0.05 on the t-table of 2.101. And so what we're doing is we're actually rejecting the null in this case. So 2.101 on the distribution is here, and our t-value is bigger than that, so it's in this shaded area right here. When our observed t is larger than the table value, we reject the null hypothesis. Remember that the null hypothesis is that there are no differences between the groups in average hourly wage. We reject that idea, which provides some support for our research hypothesis, which says that there is a difference. When our calculated t is less than the t from the table, called the critical t or t-crit, then we retain the null hypothesis, which means that it's possible that the population means are the same for both groups. But again, in this case, our calculated t is greater than our critical t, and so we have some evidence that there is a real difference in the means between the two groups. I hope this is helpful to you. What I recommend that you do is you practice. Do the first sort of half of the problems in your chapter, check your answers, and please go on the discussion board if you have questions, because we can figure this out together.